Hey everybody, I just want to show you this really cool Vertex animation texture system. It's a really performant way to animate a lot of meshes. As you can see here, I've got the seagull heading about 2,200 FPS and I'm recording. But let's say I want like 10,000 of them. Boom, no problem. Here we go, 800 FPS, no sweat. I don't know how much you've worked with animations and stuff before. This is not normal. Usually you'd be able to hit maybe like 100 animated meshes before things start to just come to a crawl. And the reason that this works is because we're taking advantage of instancing. Instancing really is basically just trying to optimize for what computers are good at and not for what they're not good at. See, computers are fast, like really fast, but moving data around is slow comparatively. So if we have a single mesh of, let's say, a seagull, and we just send that to the graphics processor with, just a giant list of every position and rotation we wanted in, a little bit of an offset, and then the animation that we want it to play, the GPU can totally just crank through that 800 FPS, 900 FPS, no problem at all. Whereas if we try to do this with a standard animation system, which is based off of, a skeleton that the CPU calculates, all the position of the vertices, and then it passes that whole deformed mesh every frame to the GPU. If it tried to do that for 10,000 meshes individually, this would crawl to a halt. So it's really just the magic of instancing. That's how particles work. We could have these flying around everywhere. As long as we're using instancing in a smart way, it would be really, really performant. So how do we achieve this? Well, turns out if you use something like Blender, it's actually not too hard. I've got that same animation here, as you can see, with bones and the standard sort of style. And if I head to my Blender preferences here, go to Get Extensions, look up VAT for Vertex Animation Texture. Here is Open VAT. Go ahead and install that. Thanks, Luke, for writing the script. This kind of just encodes, exactly as it says, encodes and previews Vertex Animation Textures, which is exactly what we want. So we'll take our main mesh. We'll head over to Open VAT. We'll put in an output directory that we want. Make sure that we have the vertex normals exported as well, just as a separate map, and perform cleanup. It's going to pack that all into a texture. As you can see, I have 74 vertices. That's going to be the width of the texture. And then 128 frames. That's going to be the length of the texture. As you can see, it rounds up to the nearest power of 2 here, just for performance on the GPU. GPUs really like powers of 2. So if you can keep your frame range and your vertex count sort of in that range, it will definitely help. But yeah, so I have 128 frames of animation here, and it loops right there, as you can see. So let's go ahead and just export this. We'll just click Create Vertex Animation Texture, give it a second. It's generating that model, those textures and everything. And there it is. That's our Vertex Animation Texture model. The first frame is broken. That's a bug in this plugin right now. Hopefully it gets fixed. But every other frame, as you can see, matches up pretty perfectly. If you really need that first frame to be correct and you don't want to just like crop it off or fix it in post or something, you might want to offset your whole animation by one frame, and then you can just crop it off in like an image editor. Because this thing just actually, if I copy this file path here and plug it in here to my file manager, it actually just pumped out basically this, just an image of vertices along this axis, frames along this axis, and you can see that first frame there is all black pixels for some reason. So we can actually just pull this open in like an image editor and just copy, this animation loops, so the first and the last frame are like almost exactly the same. So I'm just going to copy that and just move that all the way up to the top. Obviously, you won't have to work around this once the bug's fixed. But there you go. Just going to save that out. Now, as you can see here, other than this one, which I made myself, we have the vertex animation texture, the vertex normal texture, and this little JSON file. And those are the three things that we need. So I'm going to take those, copy those over to my little test project here that I was working in. And I had already copied those over, so don't really have to do that. But yeah, here we go. So we've got those textures, and then also it's generated this secondary model, this Seagull underscore vertex animation texture. And this model is special because it has a secondary UV map that has each of those vertices placed on the UVs exactly where that vertex is encoded on the texture, so that the GPU can read it off real easy. And then if we want to move down a frame, we just offset those UVs in the shader like this. We just move it like this. And as you can see, it's animating right now. See that? So that's kind of how that works. We need to export this set model with the correct UVs as well. So I'm going to just export a GLTF of those. And just that selected object. It doesn't need any crazy data. Make sure it just has those UVs, the normals, and you know, you don't need like vertex colors animation. You can turn all that off, export it, and then in our Godot project, as you can see, here we are, and we've got that seagull.glb file. But the problem is that's just a static mesh, right? So we need to get this animated. So what I've done is and I'll actually just redo it for you here. It's actually not too hard. I am just going to delete these real quick. Okay, so we have the model here, and we're going to make a custom material for it. And we're going to make a shader material. And we can just call this Seagull. And we're going to make a new shader for it as well. So, wrong button, sorry. There we go, new shader. A visual shader is fine. You can do it as a GG shader if that's more comfortable. I'm going to just call it VAT standard. And there we are. So then now in our import settings for our model, we can go ahead and use an external shader. Replace this material with that Seagull material we just made, re-import it. And as you can see here, if I pop it in the scene, there it is. Obviously, right now it's just static, right? But we have that normal texture, the animation texture, the normal texture, and also that JSON file. So now comes the fun part. We got to make that shader. It's really not as complicated as you'd think, but it is quite fun. So I'm going to just open up that standard shader. Here it is. Obviously, if you have textures for your model or whatever, you can hook those up in the fragment shader here. I don't. So I'll just add like a color parameter. Let's see, parameter. Here we are. And color parameter. And I'll just hook that up as color. So now in our Seagull material, there it is. We have a color. We can adjust it right there. Perfect. Make sure that we're using that. Yeah, it looks good. Okay. So now we can, adjust our color, and we know that that shader is working. Perfect. Well, let's do this vertex animation texture bit, shall we? Let's head to the vertex context. And what this vertex animation texture is it's just an offset from the original positions of those vertices. So if we just take the input vertex node, which is the vertice positions untransformed. We plug it in, nothing happens. But what we're going to do here is we're going to do a vector add to this here. And as you can see, if I adjust these values, it's moving all those vertices around by the amount that I have, right? But we're going to want to do this based off of, well, the texture, right? So we can just go ahead and add a texture parameter, texture 2D parameter, and we're going to have two of those. We're going to have a vertex animation texture, and we're going to have a normal animation texture, because we need to know the position and the normals of each vertice per frame. So we'll just plug those in and then add a texture 2D node after them. And that's going to just get us ready to sample that texture. Now, if you remember, that UV2, that second UV slot, was in fact what the model is using for the encoding of those vertex positions. So we're going to just plug in that UV2 into the UV of both of these sampler nodes. So we have these two textures. We're using the UV2. How do we then take the data of these textures and actually, well, turn it into animation? These textures are red, green, blue image data from 0 to 1 on each channel. But our animation is in a range from, well, whatever the add-on generated. So here it's -3 to 0.3, or it's -0.3 to 0.3, -0.1 to 0.2. So it's within this bounding box. So we need to remap these values. So let's go ahead and just add a remap node. And we're going to add a float remap, because we're going to do this per channel, simply because there's a few things that we need to switch around to do the coordinate conversion between Blender and Godot. But we're going to take also in two new parameters, and these are going to be vector 3 parameters. And it's going to be that min and max. Min and max of that bounding box. And that data is just here in this JSON file, as you can see. So min and max, for now I'm just going to move this normal animation texture stuff down. We'll talk about that in a second. So from the minimum to the maximum on the red channel in, we're going to remap the red channel from, so we're going to remap from 0 to 1 on the red channel to the minimum red channel to the maximum red channel. And then we're just going to do this for all three. So green to value, green min, green max, blue to value, blue min, blue min here, and blue max. So now we're going from 0 to 1 on each channel to whatever these parameters were. So then we can go ahead and do a vector 3 compose with these values, and we're going to go x to x, y to z, and z to y. And we're going to take this y to z one and we're going to invert it by going from 1 to 0 instead of 0 to 1. And that will convert our coordinates between Blender and Godot's coordinate systems. At that point, we can then add in that offset to our vertex, and actually from there, everything will pretty much just work. So if we go back into 3D, as you can see, our model looks exactly the same. If we pull up our shader, drag in our vertex animation texture, make sure it is set to lossless and no mip maps for import, both for the vertex animation texture and the vertex normal texture. Otherwise, you're going to have some pretty low quality animations. Okay, so now it looks like this. It looks good, but we need to take that remap info and plug it into these minimum and maximums. Now I've just done that already. I've just copy and pasted over minimum XYZ to XYZ and max XYZ to max XYZ right there. And then that's remapped our data. For context, if we hadn't done that remap and I had just plugged in red from here, green to here, blue to here, it would be up here in a corner and completely wrong. So the remap is pretty important. Okay, so there we go. Our data is now in the correct format. How do we actually animate this sucker? Well, lucky for us, that's actually not too crazy. We have our UV2, and all we have to do is offset the Y position of the UV2. So if we go ahead and do a vector compose, a vector2 compose here, and we're going to just plug that into the UVs instead. As you can see, it's moved down a little bit until we plug it back in X to X. And Y, we're actually going to control ourselves. We're going to create a couple parameters. We're going to create a float, we're going to create first of all, an integer parameter. And this is going to be number of frames. This is the number of frames in our animation. And then we're going to do a float parameter for current frame. Alrighty. So then we're going to do a simple float divide operation of the current frame divided by number of frames. And actually, we're going to do the remainder so that we just get a looping animation. And if we just plug this right into the Y component of that vector compose, if I scroll this if I set, first of all, the number of frames to 128, and then I scroll this, we are getting animation. Now, currently, each time this goes to 1, every number is going to be a single loop. So 1 to 2, 2 to 3. But if we wanted this to be frame numbers instead, then we'd have to further go ahead and divide by the number of frames. And then now, as you can see, we can just input the frame number into the shader, get the animation. But let's say we want to have that be controlled. You want to, have an auto loop functionality for the shader. You could totally just add a switch node, add a switch float here. But if we want to have that auto loop be true, we can just add a Boolean parameter here. Call it auto loop. Hook that up. Turn that on. And we're going to have a little bit of different math here. So currently what we're doing is we're saying, okay, we're taking in our current frame divided by the number of frames. We're wrapping that between, a maximum of whatever, and then we're dividing by the number of frames so that we have a 0 to 1 range, which is what our UVs are in. So if we want to have our own auto loop, we could just take the time variable that Godot has, and we just need to convert this into frames, basically. So time divided by a frame rate parameter, right? So we just take a float parameter. Although I suppose frame rate is almost always an integer, but yeah, float parameter, frame rate. And that can default to just like 24. you'll probably be using the same frame rate for all your animations. Okay, there we go. So now if we take that time and just do a simple division, time divided by frame rate is, or let's see, multiplied by frame rate, that's right, will give us what frame we're on, because that's what we need instead of current frame. So what we're going to do is we're going to move this remainder and divide to after. We're going to hook that number of frames into both of those. Just move that over, delete these. So current frame, if it's false, if not, there we go. So this is not too complicated here. Basically, here's what we've got going so far. Depending on if it's auto looping or not, we either use a current frame variable or a frame number generated from this here. And we can actually totally wrap that to within the frame range, but we're already doing that afterwards, so it doesn't really matter. But there we go. So now we have an auto loop, or we can manually adjust that current frame and animate our object. If we wanted to have a per instance offset, which, let's be honest, we probably would, we can totally do that too. We're just going to take this here. We're going to take our, well, we could do any number of things. We could do a per instance property. We could do the instance ID for some sort of random range. We could just plug that instance ID into a random range node and sort of add that to our UV offset. So that could totally work. We could do something like that. The instance ID would go into the seed here, and that would offset the animation by a random amount. We could also just do a parameter. If we were individually controlling these and not using a multi-mesh, we could just do a animation offset. And we could even do that as time or by frames, and we could do qualifier instance. So this animation offset would just get basically added in right here. There we are. So now if we have that animation offset, as you can see here, if I click on my seagull, or I guess I got to make that local. Seagull material, here we go, instance shader parameters, there's that animation offset. We can move it to any frame we want. So if we want this one on frame 60, and then duplicate it. Oops. I want to duplicate. There we go. So there's two of them, and we can just put this one on a different part of the animation. And now they're offset from each other. That could be one way to do it. I mean, really, the sky's the limit from this point. Now, this might be good enough, but you'll also probably notice that there's a few things that maybe don't look quite right. If I adjust this sun's positioning, put it really low in the sky, for instance, you can see that the lighting and the shadows and stuff, they just look a little bit wrong. And that's because the normal information, we forgot about the normal information. So really, we just got to do this exact same thing here with this remap setup again. And we're just going to copy and paste that over. Just the normal. And we're going to go from, on these, -1 to 1 for everything, as that's always what normals are. And then at the end of that, we're going to make sure that that is normalized, just meaning that the length of the vector is 1. And we're just going to do that same thing, red, green, and blue of that normal animation texture. And we're going to plug that straight into the normal. And then now, if we make sure that our normal texture is hooked up correctly, which looks like it is, and that needs, like I said, same treatment, lossless, no bitmaps. Now you can see the lighting is looking a lot more correct. See the shadowing on the wings and whatever is looking how it should versus before, right? These wings are always in shadow even though they're moving. That's odd. Now that, well, the flapping is correctly adjusting the normals. So perfect. And really, it's just that simple. From this point on, you can add any sort of crazy offsets to the animation that you'd like, and scatter these around. Like I said, you could have your manual animation offset here. You could also have, add it into that animation offset. The instance ID animation off, randomness, so that they automatically have some randomness to them. You could, really, the sky's the limit here. There we go. Instance ID is now set up. So if there's a multi-mesh, they'll all have by default different animations, but then you can also set the animation offset for the multi-mesh itself. And you can scatter these around your scene, and the performance is just going to be incredible. So hopefully that's useful. I hope that you have some fun with Vertex animation textures, and I will see you guys later.